Okay, let's go ahead and simplify this complex fraction. So we have fractions within fractions, and then we have these square roots or radicals going on here. So this is going to be a problem that's going to require a decent amount of work to simplify. But if you're at the Algebra 1 level or above, you should be able to have the math skills to do this problem. If you want to go and give this a, attempt to do this, which you should try to do this, especially if you're at the Algebra 1 level or beyond, probably give yourself a couple minutes to work on this because I'm telling you, there is a decent amount of steps you have to take to simplify this. I'm actually going to show you the correct answer in just one moment, and then I'm going to go through the solution step by step. But let me forewarn you right now. I'm going to be talking about how to work with fractions and square roots, etc. I'm going to explain steps, but I may not, because we have to do so many steps in this problem, I might be going a little bit fast for some of you. So if you see something that you don't understand, like fractions or working with some of the concepts with square roots and radicals, I'm going to suggest that you check out my Algebra 1 program or my Math Foundations course. I'll speak more about that a little bit more here in a second, but just this is kind of a warning here because once I get going into the steps of this problem, I really don't want to try to break the momentum because we do have a decent amount to cover. But before we get started, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. I absolutely love teaching mathematics, and I'm going to tell you right now, all of you can be successful in math, and I'm especially speaking to those of you that are having a tough time in math, okay? You can be successful as well. I promise you that I'm not just saying that just to make you feel better, okay? I literally mean that. Now, here's the three things you need to be successful in math. One, you need the desire to want to learn the subject, okay? You got to be willing to work hard. If you don't want to learn it, you're not willing to work hard, well, then I don't think anyone's going to be able to help you learn math, okay? We're not at the point with technology, it could just be downloaded into your brain. So you got to be willing to work hard. The second thing you need is hope. You need some encouragement. You need someone saying you can do this where you actually believe what they're saying. I'm telling you, you can do this. All right. So hopefully, that gives you the motivation not to give up, okay? But the most important thing you need is great math instruction. So when you're learning math from someone or a math teacher or some sort of program, you actually understand what's being taught. That's really, really important. When I teach math, I don't like to try to make it so technical. I like to give students everything they need, but I like to explain math in a way that all students can understand. So if you need help in your current math course, or maybe some sort of special test you're studying for that has math on it, things like the GED, SAT, ACT, maybe a teacher certification exam, or if you homeschool mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes in the description as well. A lot of students really take, at best, average notes. Okay, if you take average notes, you're likely going to get average math grades. So if you really want to be exceptional in math, learn to take awesome math notes. So prove your notes and things will get much, much better. But in the meantime, you can use my notes if you like. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and get into this. We want to simplify this expression. And again, this is going to be some, decent amount of work. I wouldn't say an insane amount, but a good amount for sure. All right, so this is the answer. Now, what you should end up with is a fraction. You should have 57 in your denominator, and then these are the terms that you need to have in your numerator. Now, if you don't have these in the exact order that I have them here, that's perfectly fine as long as you have these same terms, okay? All right, so how did you do? Well, if you got this right, wow, that's very impressive. Matter of fact, I'm going to give you a nice happy face and A++ because this was a more challenging problem. I'm going to give you like 150% and multiple stars. Back in my days, in the 1970s and 80s, the most you could get was like 100% on a test. And like your GPA, the best you can get was like a 4.0. But nowadays, you can get like, 150%, 9.2 GPAs. I mean, that's pretty awesome. So listen, great job if you got this right. Now, if you didn't get this right, don't despair. I'm going to walk through the steps. But as I kind of get going here, if you don't understand fractions well, how to work with fractions, how to do some other basic algebra skills like multiplying binomials, etc., FOIL method, Make a mental note, and I'm going to encourage you to check out like my Algebra 1 course, my Math Help program. It's probably the best course that can help you with the skills that you need in this particular problem. So let's go ahead and get started right now. All right, so here is the problem, and what we want to do is look at the numerator and denominator here as kind of separate problems. We want to simplify this and simplify this, okay? So we'll kind of do that right now. And again, there's going to be multiple steps in this problem, but this is going to be the first order of business. All right, so here we have 2 over the square root of 3 plus 1. So let's change this one. Let's focus in on the numerator here to this fraction right here. Square root of 3 over square root of 3. Square root of 3 divided by square root of 3 is in fact 1. Now I'm doing this so we can have the same denominator here. Okay, there's different ways you can approach this, but you're going to have to be able to work with fractions. Of course, you can look at this as 1 over 1. As long as you can understand how to add these two together using fractions, okay, lowest common denominator, etc., then you'll be fine. All right, so here I have two numbers, okay, two fractions with the same denominator. I'm going to be able to add these up in a second. All right, let's take a look at this denominator. Here I have the square root of 5, but really it's the square root of 5 over 1 plus 1/2. So here I need to get these denominators the same, so this is going to be a little bit different. So the lowest common denominator is 2, so I want to change this to 2, okay? So no problem, let's multiply that one by 2, but if I multiply that by 2, I'm going to multiply the numerator by 2, so this expression is going to be 2 square root of 5 over 2 plus 1/2. All right, so take a look at this, make sure you understand how I'm going from here to here, here to here. So now I have these fractions have the same denominator, so I'll be able to add them up. And then these fractions up here have the same denominators. I'll be able to add them up. And now let's go ahead and do that right now. All right, so here, here's the kind of setup a little bit more clearly. So how do we add fractions with the same denominator? We simply add the numerator. So this would be 2 plus the square root of 3 over the square root of 3. Okay, and here down in the denominator we have 2 square root of 5 plus 1. That'll be our numerator over 2. Okay. All right, so this is like the first step. So of course I already pre-wrote this out, but if you had to kind of do this in advance, you have to, just write this out step by step. And some math problems will take you a lot of steps to do. That's why you have to be neat. Always use pencil, don't use pen because you may have to do some erasing, and that's perfectly fine. Another thing that you should be doing is allowing yourself to have enough paper. Don't try to conserve paper, on your work and just cram everything in on like one sheet. Some problems, again, you're going to have to use multiple sheets, right? It's perfectly normal. All right, so now we have this expression. So it's this expression. We're dealing with the complex fraction. This fraction being divided by this fraction. So let's go ahead and take a look at the next move here, okay? So this is kind of a more complicated scenario of complex fractions. Again, these are things that you should learn like maybe at the pre-algebra level dealing with a complex fraction. And let me just show you an example like 3 and 1/2 plus 1 over 2/3. Something like this would be an example of a complex fraction just dealing with numbers. So here we have, this is our numerator and this is our denominator. So the next thing we want to do is to write this differently. The numerator is being divided by the denominator. So let's write that this way. So here is the numerator and we're dividing it by the denominator. So that is how you kind of go from this kind of complex fraction format into something we can kind of handle. Okay, so now we have to figure out what this divided by this is, and let's get to the next step. Okay, so here we got 2 plus square root of 3 over square root of 3 divided by 2 square root of 5 plus 1 over 2. And now we're talking about division. So how do we divide fractions? Remember, if you have like 2/3 divided by 1/5, the way we divide fractions is to turn this division into multiplication and flip this fraction to the right. So this is going to go to multiplication, and then we're going to flip this fraction to the right, 5 over 1. So that's what we have to do here. So we're going to go from division to multiplication, and we're going to turn this guy upside down. Okay, that's called the reciprocal. So now we're at this stage of the problem. All right, so again, lots of steps, as I kind of told you in the beginning. So we have 2 plus square root of 3 over square root of 3 times, we got to, or being multiplied by 2 over 2 square root of 5 plus 1. All right, so that's where we're at. And if you're doing this problem, and even if you didn't get the right answer, but you did all your work nice and neat, and step by step, you can kind of be grading yourself along the way. Be like, oh yeah, I got this right. Let's say we're halfway through the problem. So, that's why you want to write all your work out. So if you turn this into your teacher and you got the problem wrong, but you did a majority of the steps right, you're going to get most of the credit, or a good amount of credit for that problem. You got to write things down, and also when you're grading yourself to see what you did right or wrong, that's how you learn from your mistakes. All right, so let's go ahead and figure this thing out right now. So we have these two expressions being multiplied by one another. So here is a really important part of the next step. Notice here I have 2 plus the square root of 3 over square root of 3. Now I'm putting this 2 plus the square root of 3 in parentheses. Now the parentheses were written there, but anytime you have a sum, you're adding or subtracting things in mathematics, algebra, whatnot, I would encourage you to put grouping symbols around those sums and differences. It's going to make your life a lot easier. There's nothing technically wrong to add them in. You're not breaking the problem, but it will help you really kind of control what the next path is here, because we have to take this 2 and multiply it by this 2 plus the square root of 3. So we want to see it this way because we're going to need to use the distributor property here. A lot of students, when they don't put those parentheses in, they'll look at this problem like this. Oh, that's 2 times this, and then they'll just go 2 times 2 is 4. They'll forget to distribute the 2 to the 3. All right, so hopefully that makes sense. Let's put those parentheses in around those sums and differences. So it's going to be 2 times this, as you can see that right there, and then the square root of 3 times this right here. Okay, it doesn't make a difference, the order of multiplication. And there you go. All right, so now we have to take this to the next step and use the distributor property to figure this out. Okay, figure out the product here. So 2 times 2 plus the square root of 3, I got to distribute that 2 to both of these terms. So 2 times 2 is 4. 2 times the square root of 3 is 2 square root of 3. And then the square root of 3 times 2 square root of 5 is, let me show you it over here, just in case you don't understand this. So when we're multiplying square roots, it's like the square root of 3 times the square root of 5, and then we have this 2 over here, 2 square root of 5. Let's just look at this part of the problem here. So when you're multiplying square roots, and they're both square roots, not one is a cube root, not one's a square root, when the radicals are the same, what they call the index. So let's just focus on 2 square roots. What you do is you multiply the numbers inside the square root. So that would be 15. Okay, so this would be 2 times the square root of 15. All right, so hopefully you understand why, you understand the work here that I'm doing. So you can always pause the video and look at it more carefully. But anyways, that's how we get 2 square root of 15. And then square root of 3 times this one is square root of 3. Okay, so good amount of work, as I promised. Okay, but here's the deal. Did we finish? Are we like, hey, why isn't this the final answer? Now, if you were doing this problem and you got this as your final answer, well, I would say that that's pretty good. Okay, like you definitely did a good amount of work, but we have a problem here. Okay, here's the problem. We have square roots in the denominator. Okay, we're not allowed to have square roots in the denominator. For example, if I have like 7 square root of 3, you can't leave your answers with a square root. Well, we're specifically an irrational number. Okay, like if it was a square root of 9, I would just simply take the square root of 9. That would be 3. But when you have something like the square root of 3, square root of 2, you can't have that in the denominator. It's a big no-no in algebra and in mathematics. Okay, you're trying to divide by what we call an irrational number, so we have to rationalize. Okay, that's what they call it, rationalizing the denominator. We have to fix this up such that we have an answer where there is no square root in the denominator. Okay, so just to really make this really clear, right? Let's say you had a pizza with 8 pizza slices in it. All right, well, actually, let's do it this way. Let's say, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's our pizza. There's 8 pizza slices, and we wanted to divide that thing up by the square root of 3. Well, the square root of 3, again, is an irrational number. Okay, it's a non-terminating, non-repeating decimal. It goes on and on and on and on forever. So it doesn't make any sense. How can we split this up into, by a number? How can we divide this number by a number that never stops and never repeats itself? It's too, it doesn't make sense. So that's why we don't like to leave an irrational number in the denominator. We rationalize. So anyways, that's the next major step that we have to do, and this is a decent amount of work in and of itself. So here is our problem. How can we get rid of these square roots here? Well, we have to use something called the conjugate. Okay, this is called the conjugate, and this is stuff that you'll learn at the Algebra 1 level. If you haven't learned this at the Algebra 1 level, then your Algebra 1 class is probably more like a pre-algebra class, okay? So here is what we need to do. Notice that I have 2 square root of 15 plus square root of 3. Notice this plus sign here, right, between these two terms, okay? What you're going to do, the conjugate, is the exact same thing, but what we need to do is just change this to an opposite sign. So this is going to go to plus to minus. If this was minus, this would go to plus. That's the conjugate. So we're going to multiply both the numerator, the denominator and numerator by the conjugate. So this is called the conjugate, and all it is we take this expression down here and use the opposite sign. In this case, it's negative. Now, when we multiply, okay, the denominator, okay, times the conjugate and the numerator times the conjugate, when we do all of that work, we will finally be done. So again, a good amount of work as I promised. So let's go ahead and do that work right now. And let's focus in on doing the multiplication of the numerator first. Okay, so notice here, there is the numerator 4 plus 2 square root of 3 times 2 square root of 15 minus square root of 3. Let's figure that out right now. Okay, so we'll do that work and then we'll do the denominator work here in a second. Okay, so the way you want to look at this is basically you're going to use the same steps as what we call FOIL, first, outer, inner, last. So if you had like, for example, 2 plus y and you're multiplying that by 2x minus, actually let's do something a little bit easier there for you algebra students. Let's say you had 2x plus 3 and you're multiplying by x minus 7. Okay, you're multiplying one binomial times another binomial. So you would go first, outer, inner, last. If you don't know how to do this, you certainly won't know how to do this, okay? So first, outer, inner, last, that's what you need to kind of keep in mind when you multiply two binomials. There's some other things that you can kind of perceive or other ways you can think of how to do this problem. But basically, you're taking the same steps. Now, again, if you don't know how to do this, if you're like, I'm so lost here, well, you need to go back and review a good amount of stuff. But anyways, let's go ahead and look at the FOIL method right now. So first, outer, inner, last. I'm going to take this 4, okay, here, the first, this is the first, I'm multiplying by this first, so 4 times this. Then I'll take this 4, okay, this is the outer part, 4 times the square root of 3. The inner part is going to be 2 square root of 3 times 2 square root of 15, and then I got to take that 2 square root of 3 and multiply by square root of 3, or square root of 3. So if I misspeak anything here, describing any of these values, please forgive me as I am trying to explain a lot at once. That's why I like to pre-write all my problems out. Okay, so hopefully you can see the steps here. Let's go ahead and tackle this now. All right, so 4 times 2 square root of 15, that's going to be 4 times 2, that's 8 square root of 15, that's that result. 4 times negative square root of 3 is negative 4 square root of 3. All right, so now square root of 2 times 2 square root of 15, that is going to be 2 times 2 is 4, and then square root of 3 times square root of 15 is the square root of 45, so that's 4 square root of 45. And then square root of 2, 2 square root of 3 times square root of 3 will be 2 negative, let's just say this again, 2 square root of 3 times negative square root of 3 is going to be negative 2 times the square root of 9, right? Square root of 3 times square root of 3, square root of 9. Okay, so now let's go ahead and simplify this because we're not done yet. Okay, so 8 squared root of 15, that's as simple as we can write this. This is as simple as we can write that. here, and we can write this a little bit simpler because we have a perfect square inside the 45. So we can write this as 4 times, or we can think of 45 as the square root of 9 times 5, which is 45. 9 is a perfect square. These are perfect square values, 4, 9, 16, 25, because when I take the square root of these things, I get these nice lovely values like so. So if you have a perfect square factor in a number like this that you can factor, then go ahead and take it out. So here, like 15, that's 3 times 5, but 3 and 5 is not a perfect square, so there's really, no value in trying to simplify this. But here, I could take out this 9, so I can break this up as the square root of 9 times the square root of 5. The square root of 9 is 3. 3 times 4 is 12, so this is 12 square root of 5. And then, of course, the square root of 9 here is 3, so we have 2 times 3 is 6. So, wow, if you're still with me in this video, congratulations for having the tenacity to see this problem through, because here's the thing. Imagine I'm explaining this to you, right? I already did all the steps, but if you got to do this problem, and this is a problem that you would see in like an algebra course, you're going to have to focus and, do these steps without making a mistake, right? So yes, math is a game of focus and effort. All right, so we finally got our numerator, right? So this is our numerator. We had these fractions, so here's our numerator, here's our denominator. We have to work on the denominator, and that was a multiplication of the denominator and the conjugate. Okay, so there's that part of it. Let's go ahead and simplify that right now. Okay, so there's 2 approaches here. One, I could just use the FOIL method as I just did the previous problem, okay, the previous multiplication problem. Or I can think of it this way. If you look here, I can think of this as A and B, and these are the same numbers, right? So I could, this follows this pattern is what I'm trying to say. A plus B, then this is the same here. If I'm calling this A, this is also A, so this could be A minus B, okay? So when you have A plus B times A minus B, this is what we call the difference of 2 squares, right? So you could, if I wanted to multiply 2 things with this pattern, this A plus B times A minus B, I could just simply use the difference of 2 squared. In other words, I can square A and subtract away that B squared, and I'll get the answer. So let's do that right now. So this is A, 2 square root of 15. Let's square it. So 2 square root of 15 is what? Well, that's going to be 15 times 4, which is going to be 60. Now, if you don't know how to do that, you can kind of write that out the long way and kind of see that, in fact, that is 60. And then when I square a square root of 3, the answer is going to be 3. So 60 minus 3 is 57. So that is our denominator. So we're almost done. But let's go ahead and do this using the long way for those of you that are like, let me just do it the other way. So here's the work right now. You can use the FOIL method and walk through the same steps. And when you simplify everything down, you'll get 57. So when you're working with the conjugate, keep in mind that you can use the difference of 2 squares. This comes up. Again, we're talking about just a lot of good Algebra 1 level stuff here. All right, so this was our denominator. And now let's finally put this thing all together. So remember, we did all of that initial work. Here was our answer. We're like, oh, we got square roots down here. We got to get rid of them. So we multiplied the numerator and denominator by the conjugate. We did all of that work. When we multiplied the numerator, we got this, and we multiplied the denominator with the conjugate. We got 57. So there is our final answer. All right, so was this a challenging problem? You know what? I would say it was a decent level problem for sure. Okay, especially if you're at the Algebra 1 level. But I like doing problems like this because they're multi-skilled problems. Okay, they're going to require you to remember the things that you learned, in previous chapters. The thing about math is this. Here's like, let's say your Algebra 1 course. Here's the chapters or units of your course. Let's say, oh, I know this. Oh, when we studied that, I did well. Oh, but this one, I failed that test, and I failed this test. And hopefully we won't see that again when we get to the next chapter. But here's the deal. It doesn't work that way. You have to know all these previous skills to do these future things that you're going to be dealing with. Okay, you're going to have to rely on what you learned in the past. That's just like, kind of think of it as building a house, okay? When you start building a big structure and you start off by learning how to use a tool, here is a screwdriver. Now you have that. We're going to need to keep that, We're also going to need a hammer. We're also going to need a saw. We're also going to need, a plane or a drill, whatever the case is. Well, once you understand those tools, yes, we will be using them in future concepts in mathematics. Okay, that's why it's important to recognize what you don't know. If you understand what you don't know, that's excellent because that means, hey, you know what to work on. Because then now it becomes kind of a game of personal responsibility. Okay, I'm going to tell you right now, when I say that all of you can be successful in math, I truly mean this, but I'm also not trying to, tell you, basically what's something that's not true and saying this is going to be so easy. You can do this without any effort or any kind of struggle. No, okay, that's just like not true. All right, you're going to have to work at it, but you can do it if you want to do it. And hopefully, my videos will help you out to get to where you want to go in your mathematics journey. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.